Naming ionic binary compounds. In your reading materials, it goes through step by step how to name ionic binary compounds. So if you have one metal atom bonding with one non-metal atom, it's called ionic binary, bi meaning two, compound. And these are the easiest to name. So you write the name of the metal, write the name of the non-metal, change the ending to IDE, ide. So chlorine becomes chloride, oxygen becomes oxide, nitrogen becomes nitride, and we don't even have to look at the subscripts. They don't change the name. So here are the examples that are given in your reading. Calcium fluoride, Ca and F. Ca is calcium. Fluorine becomes fluoride. Again, ignore the subscript. It doesn't change the name. Al is aluminum. N is nitrogen. Aluminum nitride. Na is sodium. Br is bromine. It becomes bromide. So sodium bromide. Magnesium nitride. Again, ignore all of the subscripts. Now, when you come down here to the transition metal questions, right here, this changes things a little bit. You're going to have to do something a little bit special, and you're going to use Roman numerals to do this. So it shows you here, again, you're going to name the metal just like you did before, but then you have to determine the charge of the transition metal, which is that metal, that first element on your compound, okay? So you're going to determine the charge of that metal by looking at the total charge of the non-metal atoms. Because all of your charges have to add to 0, you'll be able to figure this out. So it says put the charge of the transition metal in parentheses as a Roman numeral. Don't put the positive charge, just put the number. And then you name the non-metal, changing it to ide, just as you did before. So here are two examples. Chromium 2 oxide. How do you know that you're supposed to put a 2 in parentheses here? The reason why is that oxygen, O, has a -2 charge. So if this charge right here is -2, chromium has to cancel out that charge by being a +2 charged ion. -2 plus +2 gives us 0. So chromium 2 oxide means that chromium here has a +2 charge. If I look at iron 3 sulfide, watch how this one works. This one's a little trickier. It's Fe2S3. So because this is a transition metal, I can't just name it iron sulfide. I have to tell what charge it has. The reason why, remember groups 3 through 12 here in the periodic table? These do not follow that rule that tells us, hey, it's got 2 outer electrons, so it's going to have a +2 charge when it bonds. It does not follow that rule. These transition metals, trans means change. So the way that their outer electrons are configured can change depending on what it's bonding with. So we have to be very careful that we don't just say that it has a certain charge. It may or may not have that charge when it bonds with one element versus another. So here, iron can bond in different ways, and we're going to check this by looking at our negative ion, which is sulfur. So S3, each sulfur has a charge of -2, but look, I have 3 of them. So -2 times 3 here, so each one of these is -2 times 3 would give me -6. All right, so since this is a total of -6, that means that my first part has to be a total of +6 to cancel it out. -6 and +6 cancel each other out. So it took 3 -2s to make -6. So how many positive would make times 2 give me a +6? In other words, if I have 2 of something, what does that something need to be in order for me to get 6? Well, 2 of a charge of 3 would give me 6, right? If each of these is a 3 charge, times 2 would give me 6. So if this Fe has a charge of 3, then this is an overall charge of +6. So -6 here because 3 times -2, and +6 here, 2 times a +3. So let's do one of those together because I know that those are a little harder. Here's CuBr. Let me move this up. So I'm going to look up bromine. I don't know what the charge of Cu is, not yet. So I look up bromine. Bromine is right here on my periodic table. It's in group 17, so I know it's going to have a charge of -1 because it needs one more to make 8. So my Br is a -1 charge, which means that Cu needs to be a +1 charge to cancel it out. So Cu, when I look on the periodic table, I find it's copper, so I would write copper, and in the parentheses I'm going to put the Roman numeral 1 because I know it has to have a +1 charge to cancel out this -1 charge. Copper, 1, and then bromine becomes bromide. Bromide. Now here is copper and bromine again, but now I have 2 of these bromines. Remember, each bromine is a -1. If I have 2 of them, then I have a total of a -2 charge, which means that this has to have a +2 charge to cancel it out. So now I don't have copper 1 bromide, I have copper 2 bromide. Copper 2 bromide. Now let's do one that's a little bit harder, like this one right here, Fe2O3. O, oxygen, is in group 16, so it's going to have 6 outer electrons, which means it needs 2, so it has a -2 charge. So this O has a -2 charge, but there are 3 of them. 3 times a -2 gives me -6. So I know that this total has to have a +6. So what I'm going to do, I'm going to take that 6 divided by 2, right, because it takes 2 of them to give me 6, so 6 divided by 2 will give me 3. So each of these has to have a 3 charge, +3, because +3 times 2 gives me the +6 that I need. So this is iron 3 oxide. Iron 3 oxide. Okay? And in case you are not sure for Roman numerals, if you do end up with any that are a 4 charge, the Roman numeral 4 is IV. I don't remember if you have any of those on this page or not, but you will need to know it at some point, either on your paper or on a quiz. If you still have questions, please make sure you ask.